into the diagram. Transfer all the information given into the diagram. That is step number 3. And then last one, step number 4, solve the problem by using the equations given, by using the equation that you have learned. Okay? The equation of any formula. Okay? Solve the problem. Okay, so now let's look at question number 5. Okay, for question number 5, we have 1, 2, 3, 4, 5. 5 rows that we need to complete. Or in other words, they have 5 small questions there. Okay, this is question number 1. Next, this is question number 2. Okay. This is question number 2. Here is question number 3. This is question number 4. And last one is question number 5. Okay, let's do one by one. We have to complete the question number 1 first. Okay, for case number 1, we are given pressure and the value of X quantity. Okay, these are the information given. As I said just now, step number 1, list down all the information given. Okay, for question number 1, wait a minute. Let me take my tutorial question first. Okay. For question A, we are given pressure and quality. Pressure 325 and quality 0.4. Okay, let me share with you my board so that you can see how the way how we solve the problem. Okay, for question 5A. Okay, question 5A. Please have a look at your questions. Okay, I hope you have your tutorial in front of you, your hand. So pressure is given. The value of pressure is 325. Then we are given quality as well. Quality X is 0.4. Okay, this is first step. Okay, first step. This is step number 1. List down all the information given. Okay, and then for step number 2, as I said just now, draw PV or TV diagram. Okay, so here P is given, pressure is given, so we draw TV diagram. Kita lukis temperature lawan dengan specific volume diagram. Sebabkan tekanan diberikan. Okay, kita ada nilai tekanan, that's why as I said, draw TV diagram. So this is the curve, this is pressure, constant line. Okay, so this is step number 2. Step number 3, transfer all the information given into the diagram. So look at step number 1. We are given 325 kilopascal and X 0.4. So transfer this value to our diagram. Pressure is 325. So Just put it here, right here, 3, 5 kilopascal. Okay, what else? X 0.4. So in our diagram here, we cannot put 0.4 because it's impossible. But as what we learned in chapter number 2, if they have value of X, okay, meaning that the phase or the region of substance is actually around here, somewhere here, this region. So meaning that this is pressure 3 to 5 kilopascal. So somewhere here, okay? Somewhere here is the point of our substance. Why? Because as I said, as what we have learned in chapter number 2, at this point, the value of X is 0, right? On the other hand, at this point, okay, the value of X is 1. If we have value 0.4, for example, meaning that the position or the location of the substance is somewhere on this line or on this region. Okay. So for example here, this is where X equal to 0.4. Okay, 0.4. Okay, this is step number 2 and number 3. So we have done step 1, step 2, and step 3. Okay, and then for step number 4, solve the problem. So we have to determine what? If we look at our question, we have to complete temperature. We have to find temperature. And then what else? Enthalpy. And last one is phase. So we have to know the phase. Okay, so look back at our diagram, then we can get the answer. Okay, for example, okay, for example, phase. Phase, since the point is located here, somewhere here, 0.4 on this region, we know that the phase is what? Saturated, mixture, or in detail, saturated, liquid, vapor, mixture. Okay, so we have done for the first answer. Second, temperature. For temperature, in order to determine the temperature of this point, then we have to write or to connect or to draw this horizontal line. Okay, so at here, as what we learned, this is where the saturation temperature at the given pressure. Okay, so this is the temperature that we need to find. So this T is actually equal to T saturation at the given pressure. The given pressure is 325. Okay, if you have any question, you can interrupt me. Okay, if you have any question to ask, please interrupt me, and I will try to answer your question. Okay, so now the temperature for this state is T saturation at 325 kilopascal. So now you have to look at your booklet, table booklet. You have your own, right? So pressure is given 325 kilopascal. Then you have to look at water table, table A 4 or 5, but specifically look at table pressure table, table A5. A5 is pressure table for water. Okay, the substance here is H2O. The substance is H2O. So therefore, we have to look at pressure table for water, A5. Don't look at table A12. A12 is also pressure table, but it is for refrigerant, not water. So please don't confuse between table A5 and 12. 12 also pressure table, but for refrigerant. So in our case now, our substance is water. So we choose table A5. You have to look at table A5, pressure table for water. So find 325 kilopascal. Go for 325 kilopascal and get the saturation temperature. So the value is 136.27. 136.27 kilopascal. Okay, so this is the second answer. Okay, next, H. How to solve H. Okay, as I explained in my lecture, for this x-axis here, which is specific volume, it actually can be changed into other property. For example, H. We can change. You can change from V to H or U, internal energy, or enthalpy, or even entropy S. So for this case, we can change to H because we need to find the enthalpy. So in order to determine the enthalpy here, okay, so you have to draw this vertical line. So here is H that we need to determine. Since the state is saturated liquid vapor, in order to determine the enthalpy, we have to use the equations we have learned in chapter number 2. Okay, for the case of saturated liquid vapor mixture, the equation of the property is HF plus X HFG, right?
Betul.
Ya.
Bukan yang 136.27 tu Celsius ke?
Sorry, Celsius, sorry. Okay, terima kasih. This is not kilopascal but degree Celsius. Okay, degree Celsius. Thank you. Okay, let's continue for the enthalpy. So for the case of enthalpy, okay, for the case of saturated liquid vapor mixture, we have to use the equations in order to determine any properties, either specific volume, internal energy, enthalpy, or entropy. Okay, for the saturated liquid vapor mixture. So now we have to find HF. HF at the given pressure 3 to 5 kilopascal from the table. Then find HFG at the same pressure 3 to 5 kilopascal. Okay, so look at 3 to 5 kilopascal, table A5, get the HF and HFG. So once you have the value here, okay, then solve the equation here. So can someone calculate for me the value of H? Berapa?
1435.35.
1435.35.
Ah,
1435.35 kilojoule per kilogram. Okey? So itu saja. Caranya begitu. Tak susah lah sebenarnya. Yang penting kamu boleh, kamu tahu baca diagram, kamu tahu analyze the diagram, PV or PV diagram, and then you know how to, next one, you know how to read the table. Ia menjadi susah sekiranya kamu tidak faham salah satu daripada ataupun kedua-dua daripada apa yang saya terangkan tadi, table, diagram dan juga table. Kalau you faham kedua-duanya, then you can find the answer. Okay, itu yang A. Okay, next for B, let's do 5B. Okay, for 5B, number 5, okay, untuk 5B, step number 1, for step number 1, to mean find the list down all the information given. So in 5B, we are given temperature is 160 degree C, and enthalpy 1682. Kilojoule per kilogram. Itu saja yang diberikan. Okay, then move to step number 2. Okay, satu lagi tips. untuk menyelesaikan sesuatu masalah dalam thermodynamics ni, paling kurang mesti ada 2 properties yang diberikan. Sekiranya satu property sahaja diberikan, then we cannot solve the problem. So again, in order to solve any problems in thermodynamics, we need at least 2 properties. Otherwise, if less than 2, then we cannot solve the problem. Okay, that is another hint. So, untuk inilah menyelesaikan masalah. So here we are given 2 properties, temperature and enthalpy. Just now we are given also 2 properties, which is pressure and quality. So mudah untuk selesaikan masalah. Okay, let's continue. Draw PV or PV diagram. So in this case, temperature is given. Okay, so we draw P versus V. So this is temperature constant line. Okay, and transfer step number 3, transfer all the information given into our diagram. Okay, temperature is 160. So here the value is 160 degrees C. H is 1682. So we have to change our V here into H. Okay, and then after that, get this value, this value H. F and this value H G. Why? Because we need at least one value, 1 or 2 value in order to determine the position, the location of 1682. Kalau kita tak ada nilai reference, then we cannot plot this 1682. So, as I said just now, find this value HF and HG at 160 degrees C at the given temperature. Okay, at the given temperature. Yang ni pun sama, at the given temperature. Okay, so look at temperature table. Now is temperature table. Just now is pressure table, but now temperature table A4 for water. Okay, so go for 160 degrees C and then get the value of HF and HG. HF is 675, right? 675.47. HG is 2757. 2757.5. Okay, the given value is 1682, which is in between these two values, in between HF and HG. Now we know the point of 16 somewhere here. Okay, we can assume somewhere here, as long as in between both value 675 and 2757. This is 1682. Okay, this is the H that is given to us. Okay, so then you can draw a vertical line to our temperature constant line. So therefore, here is the point, the location of our phase. So meaning that the phase should be saturated liquid vapor mixture because it is located on this region, right? On this region, a saturated mixture region. Okay, number 4, step number 4, solve the problem. Number 3, we have transfer all the information given, right, into our diagram. Now step number 4, solve the problem. So we have to find pressure. Then what else? Quality. And last one is phase. For the phase, easy because we know the phase now. The phase is what? Saturated mixture, or you can write settle in full text, liquid vapor mixture. Okay. What next? Pressure. Can find pressure because if we draw a horizontal line, since the point is here, okay, since here is the point, okay, so draw a horizontal line to pressure exists. So the pressure, the point here is P sat, right? Saturation pressure. The given temperature. So this value is actually same with the pressure that we need to find. So P here is P set at the given here, 160 degrees C. So look at table A4, temperature table. At 160 degrees C, the pressure is, the saturation pressure is 618.23. So the value is 618.2 kilopascal. Okay. And then for X, we can use the equation because we have all the values of enthalpy. We have enthalpy, we have HF and HG. Right, so as what we learned before, H equal to HF at the given temperature plus X H FT at the given temperature. Okay, so we have all the value, then we can find the X. Is H minus HF divided by H FT. Okay, so what's the answer? Please someone calculate, find the value.
Betul.
Ya,
0.483.
0.483.
So kalau macam ni kan, kita orang kena bundarkan dia kepada satu titik perpuluhan je ke, ataupun kita salin je tiga titik perpuluhan tu?
Sebaik-baiknya 2 titik perpuluhan.
Oh, dua kan?
Sebaik-baiknya 2.
Oh, okey doktor.
2 ataupun 3 lah. Jangan 1. Okay, jangan 1.
Oh, faham.
2 ataupun 3, okay, acceptable. Okay, so ni nilai dia lah, 0.483. So I hope betul lah yang lain. Kalau tak ada rakan lain yang komen, so maknanya nilai ni betul, 0.483. Okay, so kita dah selesaikan 2. We have done two question for number 5. And then let's continue. Ada soalan tak setakat ni? Simple senang Saya based on my experience, this is the easiest way to solve the problem. Semua sekali daripada chapter 2 sehinggalah chapter yang ke-6. Kalau kamu belajar nantilah sampai penghujung semester, kaedah untuk menyelesaikan masalah dalam thermodynamics ni, beginilah cara. Buat step 1, step 2, step 3 sampai step 4. Okay, step 4 ni kita apply je lah apa saja equation yang kita dah belajar. Okay, next soalan C 5C. Dia makin lama makin susah sikit lah, tapi tak apa. Since we know we have learned the method, the steps on how to solve the problem, so it's not difficult for us. We don't have to worry. Okay, C. For C, we are given pressure 950. The what? Step 1 dulu. Okay, step number 1. Step number 1, pressure. List down all the information given. Pressure is given 950. Saya lambat sikit tulisnya sebab saya menggunakan mouse untuk menulis ni. So dia lambat sikit lah. Sebab saya tak biasa guna papan tu. Pen. Dia tak berapa sensitif dengan tulisan. Okay, pressure is given. Next is X. X is given. So X here is 0. Kosong. Okay, so we have done for step number 1. Step number 2. Draw the PV or TV diagram. Okay, so now pressure is given. Since pressure is given, we have to draw PV. So PV. So here is the pressure constant line. This is our diagram. Step number 3. Transfer all the information given into our diagram. Step number 3, masukkan nilai. Masukkan semua nilai dan dapatkan lagi maklumat-maklumat yang dapat membantu kita. Okay, X is 0. So as what I explained at the early of this session. Okay, at this point, the X is 0, right? here x is equal to 1. So x, the given x is 0, therefore the location of, or the point of the substance, the phase is here. Okay, di situlah titiknya. So kita dah transfer value, and then we can, as I said, after you transfer all the value into our diagram, still in step number 3, can find another value, additional information. Okay, sebab kita dah belajar. So di sini pun kita boleh cari, di sini pun kita tahu this is T set, right? So all of this property you can find from the table, yang mana dia boleh membantu kita nanti. Okay. Here is what this case B lah ini adalah BF at the given pressure. Okay. So ini maklumat-maklumat tambahan yang dapat membantu kita untuk menyelesaikan masalah ini. Okay, so we have done step number 3, then move to step number 4. Step number 4, we have to find what? We have to find temperature tadi apa? Enthalpy dan juga phase. Enthalpy dan juga phase. Okay, so untuk phase mudah So phase mudah sebab if we look at our TV diagram, then we know the phase is steady. So the phase is what? Siapa tahu? Apakah phase-nya? Saturated liquid. Okay, so ini ada phase ni sebab dia terletak di point sini. So bila point sini dia ada saturated liquid. Kemudian temperature. Temperature of this point, if you drag a line to temperature axis, then here is T set, T saturation. The T saturation is also T temperature for this state, for this phase. Okay, so dia adalah sama lah sebab ni yang kita nak cari, T-nya. So T here is actually same as T saturation at the given pressure. Okay, pressure is 950. Look at table A5, pressure table for water. Go for 950 kilopascal and get the value of T saturation, which is 177.66. 177.66 degrees C. Okay, then what else? H, enthalpy kan. So for enthalpy, you can actually change this axis from specific volume to H. So now here this point is HF at the given pressure. Okay, point sini ni, kalau you drag, kalau you bawa dia ke bawah, dia adalah sama dengan HF. Yang mana H inilah yang kita nak cari. Okay. So H yang kita nak cari sebenarnya sama dengan HF sebab posisinya sama, lokasinya sama. Okay. At the same table, A5 and at the same pressure 950, find HF 752.74. 752.74. Kilojoule per kilogram. Okay, so selesai untuk C. Okay, next D.
Doktor,
Yes.
so kiranya untuk yang H yang ini kita tak payah guna yang HF tambah X HFG lah, kan?
Tak perlu.
Uh,
Kalau kamu nak pakai pun boleh. Kalau kamu
tapi
pakai
kalau pakai jadi macam lain sikit.
sama. Cuba tengok. H, HF tambah X. Kan? HFG. Right. Betul tak? HF berapa? 752, right? 752.
Sama.
Ah,
Salah itu. Okey.
berapa? F ni kosong kan? Okay. Sama. Kan? Okay, ada soalan lain? Yang tak bertanya tu saya assume kamu faham ya. Kalau yang tanya tu confirm dia dah faham sebab dia yang tanya dan dia dapat jawapannya. Okay. So yang tak bertanya saya assume kamu faham. Kalau tak faham sila tanya. Okay, next. Next adalah D 5D. Okay, 5D. For 5D, we are given temperature and pressure. Temperature, pressure. Temperature is 80. 80 degree C. Pressure is 500 kilopascal. Okay. Then draw TV or PV diagram. In this case, both temperature and pressure are given. As I said earlier, if temperature is given, then we draw PV diagram. And if pressure is given, then we draw TV diagram. But for this case, both temperature and pressure are given. So now it's up to you. You can draw TV or PV diagram. Sebab apa? Sebab kedua-duanya diberi. Temperature and pressure both are given. So it's up to you. If you want to draw TV diagram also can. PV diagram also can. But for me, I prefer TV diagram. Based on your preference lah. Saya suka TV diagram ni. Saya ingat satu tu. Jadi saya ingat satu, yang kedua saya tahu dah. Saya tak perlu, saya ingat dua-dua. Kan? So, I prefer TV diagram. So, this is pressure. Pressure constant line. Okay. Next, step number 3, transfer all the value given into our diagram. Okay, pressure is 500 kilopascal. 500 kilopascal or can be 0.5 megapascal. Okay. So how about temperature? Temperature is 80 degrees C. So we cannot plot the value yet because we have to know at least one value in order to plot the value of 80 degrees C. So as a reference, you have to determine this one. Get this saturation temperature. Once you know this T set, then you can you know how to plot or where to plot 80 degrees C. Find T set first. Berapa T set can someone find for me? T set at the given pressure. Berapa nilai dia? Nilai T saturation. Berapa nilai? Berapa nilai?
151.83.
151.83. Okay, correct. 151 lah. Saya letak 151. Dia 0.83 kan? Okay, it's okay, never mind. The given temperature is 80 degrees C, which means the value is lower than T set. Okay, T set. So maksudnya 80 degrees C is somewhere here. Bawah T set. Okay, so you can draw a line to this pressure constant line. So here is the location of our substance. Di sinilah tempatnya. This point. Okay. It can be here, it's up to you lah, as long as di bawah T set, itu adalah point dia lah, di situlah tempatnya. It can be somewhere, it can be here, or you can write here, or even here, as long as less than 155. Okay. Alamak. Okay. Okay, so somewhere here lah, somewhere here. This one. This is the point. Okay. So as I said just now, after you transfer all the information given, you can find another information, additional information based on what you have learned in this diagram. So yang ini adalah nilai B yang perlu kita cari. Ataupun H. Dalam case ni kita cari H kan. So, what else? Nombor 3, step nombor 4, step seterusnya. Next step, solve the problem. So, for D, we have to find enthalpy H. Kemudian X, quality. And last one is phase. So back to our diagram. Look at our diagram. Find the phase. So if you look at our diagram, the position is here. Okay. So meaning that this point is located in compressed liquid region. Okay. This here is compressed liquid region. Yang di sini semua compressed liquid region. So therefore the phase for this case is compressed liquid region, compressed liquid phase. Compressed liquid. And then what else? X. Berapakah nilai X? We have learned just now, at this point, the value of X equal to 0. And this point, the X is 1. Okay. If you look at your lecture note, the value of X is 0 to 1. Dia tak ada negatif, dia tak ada lebih daripada 1. But for this case, the point of our phase is here, okay, compressed liquid. So therefore, the value of X is actually can put as NA. NA ni tak berkaitan lah. Sebab kaitan X hanya antara 0 sehingga 1 saja. Tak ada pun nilai X negatif ataupun lebih daripada 1. Tak wujud. Because X quality is a ratio. It is ratio. Kalau ratio, nilai dia daripada 0 sehingga 1 saja. Okay, so pastikan kamu ingat compressed liquid tak ada nilai X. So put NA not applicable ataupun tidak berkaitan. Okay, that is the answer. NA. Next is enthalpy, H. So for enthalpy, this part C, this exists, B exists, you can change into H. So we assume now the axis is H, enthalpy. Okay, for the enthalpy, have learned right in chapter number 2 for compressed liquid, they have a rule ataupun principle. Buka balik your lecture note. They have a rule for compressed liquid. As stated in the lecture note, any properties for compressed liquid can be approximated as ni maknanya boleh dianggap sebagai H F at the given temperature. Any properties, sama ada dia specific volume, internal energy, specific enthalpy ataupun specific entropy, can be approximated as F at the given temperature. Lihat balik nota kamu. Ada dinyatakan di situ hukumnya untuk compressed liquid sahaja. Yang lain-lain tak boleh pakai hukum tersebut. Cannot use the principle for other phases. Only applicable for compressed liquid phase. So, for this case, the H here, by using the principle, the value of enthalpy for compressed liquid is HF at the given temperature. The given temperature is 80 degrees C. Okay, 80 degrees C. This is the given temperature. So look at table, temperature table A4. Find HF at 80 degrees C. Berapa nilai HF at 80 degrees C, degrees Celsius. Berapa dapat? Please share the value.
Tiga 35.02.
335.02. 335.02 kilojoule per kilogram. Okay, betul. So ini untuk D. Ada soalan? Kita move to, ada? Tak ada? Kalau tak ada, we move to next question 5E. For 5E, kita diberikan tekanan dan juga enthalpy. So for 5E, we are given pressure which is 800 kilopascal. Dan juga enthalpy, right? Enthalpy 3161.7. Okay, next draw TV or PV diagram. So for this case, pressure is given and we draw E versus D diagram. This is pressure. Okay, the pressure is 800 kilo Pascal. Ataupun you can write as 0.08 mega Pascal. Sama je. Okay. Enthalpy is 3161.7. So we cannot plot this value yet because need at least one reference value. Otherwise we cannot plot. So yang ni you boleh tarik lah. Tarik, kita tahu ni adalah T saturation. At the given here. Okay, at the given pressure. Okay, for H, so this B you can change to H. That's what we did before. Find this one, HF. This one, HG. Okay, get this value first. So at 800 kilopascal, the value of HF adalah 720.87. 720.87. HG 2768. 2768.3. The given H is 3161, which means higher than HG lah, somewhere here. This is 3161.7. Dia mestilah di sebelah kanan HG sebab nilainya lebih besar daripada HG. Okay. So after that, draw vertical line. Gunanya untuk apa? Untuk kita tahu region-nya, phase-nya. So the point is here. It is located on this region, superheated vapor region. So then we know the phase lah. Okay. Okay, next solve the problem. So we have to determine the temperature. We have to find temperature at this point, and then we have to know the X, and last one is phase. Phase is very easy. We know the region, then we can determine the phase. Okay, the phase is what? The phase is superheated vapor. Write in full sentence. Okay, superheated vapor. How about X? X, as I said just now, the value is in between 0 and 1. Okay, so 1 is located here. This is 1. Larger than 1, not relevant. So we can write NA for this case. Not applicable. Because the point is here. Okay, we don't have any value of X which is larger than 1. So put or write NA, not applicable, tidak berkaitan. Okay, next is temperature. So for temperature, if we want to find temperature, we need to drag this line, right? As usual, we need to drag the temperature axis. But for this case, we still don't know the value. We can find T set from the table, pressure table, right? So at 800 kilopascal, you can find the T saturation. Tapi untuk T ni, okay, lain sikit lah. Okay, we have to look back to the phase. So the phase is superheated vapor. For the case of superheated vapor, the table is not A4 and A5 anymore, but A6. A6 is a table for superheated vapor. So please look at table A6. So in table A6, they have a lot of small tables where the pressure is different between each other. Okay, we have small table for pressure 0.01 megapascal until 60 megapascal. If you look all the table A6, we have small table of pressure 0.01 megapascal until 60 megapascal. So for this case, the phase is superheated vapor. So now we have to look table A6 in order to determine any properties. Okay, now I will show you, I will teach you how to get the data from this table A6. Okay, now the pressure given is 0.5 megapascal. Right. So look, find 0.8 megapascal column. First, find the 0.8 megapascal column. If you can find, okay. Kalau you tak dapat, beritahu saya. Dah jumpa tak? Table 0.8 megapascal. Okay. Now, you are in column of 0.8 megapascal. Okay. So in this column, they have a list of value for specific volume, internal energy, enthalpy, and specific entropy. On the left side, they have a value of temperature. kan, bermula daripada T set sehinggalah 1300 darjah Celsius. Nampak sebelah kiri sekali, ujung kiri sekali dia ada senarai nilai temperature, suhu daripada T set sehinggalah 1300 darjah Celsius. Nilai T set untuk setiap table adalah seperti tertulis di sebelah pressure tersebut. Contoh, untuk kolom 0.8 megapascal, the saturation temperature is 170.41 degrees C. Okay, itu maksudnya. Okay, now the pressure is 0.8 megapascal. After that, we are given entropy. Entropy is 3161.7. So, tadi saya beritahu kamu kita ada senarai value untuk entropy, right? Untuk kolom 0.8 megapascal, the first value of enthalpy, so enthalpy the first value of enthalpy is 2768.3. Sehinggalah nilai tertinggi 5412.2. Kolom 0.8 megapascal. Jangan tengok kolom lain. Tengok kolom 0.8 megapascal sahaja. Sebab pressure kita 0.8 megapascal. So, di kolom 0.8 megapascal, nilai enthalpy yang terendah adalah 2768.3. Manakala yang tertinggi adalah 5412.2. Okay. So the given enthalpy is 3161.7. So you dapatkanlah nilai 3161.7 dalam list tersebut. Ada ke tidak? Tak ada kan? Yang ada adalah 3162.2 dan sebelumnya adalah 3056.1. Right. So nilai yang diberikan 3161.7 terletak di antara 3056.9 dan 3162.2. Okay. That means right here. The enthalpy. The given enthalpy is 3161.7. The nearest value of enthalpy is 3056 0.9 and then 3162. Point 2. Okay. Then get the temperature. Berapa nilai temperature pada 3056.9 enthalpy? Temperaturenya adalah 300. Untuk 3162.2 suhunya adalah 350. Meaning that the temperature is in between 300 and 350. Okay. So in order to determine this value, you have to use linear interpolation. We have learned in engineering mathematics, right? Subject last semester or in the previous semester, mudah belajar. So apply linear interpolation, then you can find the value of temperature. So linear interpolation, you have to refer back your lecture note. Okay? I just show you the way, and I'm not going to explain linear interpolation. So nak dapatkan ni, apa yang perlu kamu buat adalah okay, let's say this is temperature T yang kita nak cari, tolak dengan 300 bahagi dengan 3,5 tolak 300. This one sama dengan 1 61 7 tolak 30 6 dan bahagi dengan 162 2 dot 30 56.9. Okay, so from this linear interpolation equation, find the P. Okay, so once you have this value, then you can put here. Itu kaedah untuk this compressed liquid, superheated vapor. Ada soalan tak? Okay, okay, we have done question number 5. Next, last question. Kita pilih 2 saja. Selebihnya kamu perlu buat, kamu perlu cuba buat. Kalau kamu tak buat, memang tak jadi lah. Penerangan yang saya berikan ni, memang kamu akan lupa lah. Walaupun kamu fokus hari ini. Okay, so you have to try after this the rest question number 6, 7. Yang seterusnya kita akan lihat question 8. Question nombor 8. Kamu ada kan masing-masing tutorial. I can share first. I can share with you the question. Okay. Okay. So we have done question number 5. We have completed this table. Next is question 8. This one. Okay. Question 8. A piston cylinder device initially contains 50 liter of liquid water at 25 degrees C and 300 kilopascal. Heat is added to water at constant pressure until the entire liquid vaporizes. So this is the case study. So from there, we have to determine the mass of the water, the final temperature, and total enthalpy change. D show the process on TV diagram with respect to saturation line. So you can take picture. Kalau tak ada tutorial di depan, you can take a picture of this question. Sebelum saya pergi ke whiteboard tadi untuk tunjukkan kaedah menjawab. Okay, tambah. Okay, next let's try question 8. Okay, the way how we solve the problem still same as what we did in question number 5. Saya dah banyak kali cakap. Kita ada 4 step, we have 4 steps. So, let's try a piston cylinder device. Step number 1. Okay, step number 1. Step 1 is down all the information given. Okay, step number 1, list down all the information given. So here we are given volume B besar, 50 liter. Then of liquid water at temperature 25 degrees C and 300 kilopascal. So T1 is 25 degrees C. T1 is 300 kilopascal. Why I write T1 and P1 number 1? Because as stated in the question, heat is added. And here we have initial condition and final condition. That's why I put 1. 1 means that initial condition. Heat is added to water at constant pressure until entire liquid vaporizes. Okay. So from this question, we can have some clues. The first clue is constant pressure. Constant pressure means that final pressure of P2 is equal to P1. Okay. Until entire liquid vaporize. Okay. I think that's the clue that can be get from the statement. Okay. This is the information given to us. Okay. Next, step number 2. Step number 2, draw the PV or PV diagram. So in this case, pressure and temperature are given, both are given. So it's up to you, as I said, you can draw PV or PV diagram. Since pressure and temperature both are given, so for me, I prefer to draw P versus V. This is pressure. Okay. Step number 3, transfer all the information given. Volume 50 liter. Before that, we have to find this one, change this one, liter into meter cube. Okay. Please make sure all the units are in SI standard unit before we solve the problem. Okay, for example, here 50 liter, berapa 50 liter equal to 0.05. Kamu tukarkan semua dalam bentuk SI unit sebelum menyelesaikan masalah. Jika tidak, jawapan kamu salah. Okay, 0.05 meter cube, sorry, 0.5, sorry, mistake. 0.5, okay, 0.5 meter cube. Okay, next, transfer all the information given into our diagram. Temperature 25, we cannot put yet, but pressure 300, we can put it here. P1 is 300 kilopascal, and this 300 kilopascal is actually final pressure as well. P2. Okay, for the temperature, in order to find the 25 degrees C, the location of 25 degree C, we have to know this one, P set, as our reference value. So find P set. At the given pressure. So look at pressure table, table A5. At 300 kilopascal, the saturation temperature is 133.52. 133.5. Okay. The given pressure is 25 degrees C, which means it's somewhere below than T saturation. So somewhere here, 25 degrees C, below than T set is 25. Then you can draw a line to pressure constant line. This is our first state. Okay, keadaan pertama, initial state. This is our initial state. Okay. Okay, now move to step number 4. Okay. Before we move to step number 4, look at your question again. Sentence number 2. Heat is added to the water at constant pressure until entire liquid vaporizes. So they have another clue there. Okay, another clue is entire liquid vaporized, which means the phase number 2, final phase of phase 2, or final phase is saturated vapor. Ini clue yang penting. Entire liquid vaporized. That is saturated vapor. Maksudnya saturated vapor. Keseluruhan substance meruap. So it is saturated vapor. Since the phase 2 is saturated vapor, then we can plot point number 2 here. Ini adalah point number 2. Final state. So the phase transformation is from state 1 to state 2. Heat is given kan? Heat is given, mestilah suhunya bertambah kan, panas. Okay, now let's answer the question. So question A, find the mass of the water. You have to find mass. Okay, so how to find mass? We have learned, right? As I said, for step number 4, by using equations, solve the problem. So we have to recall back, apply all the equation that we have learned. Okay, for example, for A here, in order to find mass, can use this formula or this equation. V volume equal to mass times specific volume. Okay, so mass is equal to V over specific volume V. We have V is 0.5 megapascal, 0.5 meter cube. How about this V? This V is actually V Vf at the given temperature. Why I said Vf at the given temperature? Because if you look at your TV diagram, this is point 1, right? Initial state, initial phase. Drag this line, draw this vertical line to here. This is V. This V is Vf at the given temperature. Because this point, state 1, the phase is compressed liquid. Tadi kan kita dah jawab soalan tentang compressed liquid kan. So we can apply the principle, the rule. Any properties for compressed liquid can be approximated as F at a given temperature here. Okay. Nombor 1 ni, initial state dia adalah compressed liquid. So since the phase is compressed liquid, then any properties for compressed liquid can be approximated as F at the given T. Jadi UF at the given T, HF at the given T, SF at the given T, dan juga VF at the given T. So, find VF. Berapa nilai VF? Pada suhu 25 darjah Celsius. So look at temperature table. Temperature table, the value of VF at 25 degrees C is 0.001. 0.001,003. The cube per kilogram. Okay. So berapa jawapan ni? Tolong kira kan? Berapa nilai M? Tolong sharekan nilai M. $49.85. Tak ada yang kira kan?
Pak 9.85.
49.85 kilogram. Okay. Sama saja seperti yang kita buat soalan nombor 5 tadi. Cuma lainnya situasi saja. Okay. So ini untuk A, untuk B. For B, what is the final temperature? Final temperature is T2. Kita dah tahu tadi, 2 is, this is 2. Okay, this is 2. The phase is saturated vapor. So kalau kamu lihat TV diagram, nilainya adalah 133.52 temperature ni. 133.2 degree Celsius. This value. Sebab dia sama garisan. Garisan yang sama dengan di set. Okay. Untuk B, untuk C, determine the total enthalpy change. Total enthalpy change, I already mentioned in my lecture last week. If you find terms of change, change here means that final minus initial. Okay. If you find a term of change, it means final value minus initial value. That is the meaning of change. So enthalpy change, or can write delta H, uppercase of H, right? Bukannya H kecil, H besar sebab dia enthalpy. So H final, enthalpy final H2 minus H1. Okay. Or we can write as well as M bracket small h2 minus small h1. Okay, so if you look at this equation, we have M kita ada, but you need to find h2 and h1. You have to find this both value. From where? From this diagram. Okay, so look at our diagram. H2, as what we did in question number 5, we can change this V 10 to H. So sekarang ni bolehlah kamu cari. So grab this one. This is H2. This H2, since the phase is saturated vapor, it is same as Hg. Hg at the given pressure. Yang di sini pula 1, you can drag this one. You can apply the same concept as this. H equal to Hf at the given temperature. Okay. Sebabnya nombor 1 ni, initial state, dia adalah compressed liquid. So we can apply the principle. Any properties for compressed liquid can be approximated as F at the given temperature. Sama je macam ni. Okay. F at the given temperature. So fine. Solve this one. F is given. H2 adalah Hg at the given pressure minus H1 adalah Hf at the given temperature. Okay, so dapatkan kedua-dua value, then you can find the final answer. The final answer should be 130.6 megajoule. 130.6 gigajoule. Okay, this is how we solve the problem. Kaedahnya sama macam kita buat nombor 5 tadi. Okay, so next one, last one, D, show the process on a TV diagram with respect to circulation lines. So what we draw here, this one, okay, this is the answer for D. Apa yang kita lukis di TV diagram ini, itu adalah jawapan untuk D. So that's why I ask you to follow this step. Step number 1 until step number 4. Dalam setiap step tu ada jawapan. Okay. I think that's all for tutorial number 2. The rest you have to try by yourself. Apply what I teach you on this session. Follow the steps. Step 1, 2, 3 until step number 4. Okay. Should be no problem if you follow my instruction, my explanation. Kalau you tak follow mungkin payah sikit lah. Okay, so ada apa soalan tak sebelum kita tamatkan sesi kita petang ni?
Tak ada doktor.
Okay. Yang lain ada? Okay, saya harap ramai antara kamu yang faham penerangan petang ini, discussion kita petang ini. Mana pelajar yang tak faham, silalah tanya pada rakan-rakan yang lain. Okay, and then next week, kalau sebelum tu kalau nak tanya apa-apa pada saya, please make sure you text me on working days. Okay, working days between 8 to 5. Otherwise, I mungkin tak akan reply your answer, your message. Okay, if you have any question to ask me, make sure you text me within working hours and working days. 8 to 5, Monday to Friday. Otherwise, not going to reply your text. Okay, ataupun you can ask me during our live session. You have plenty of time to ask me. Okay. Then next week kita akan ada juga tutorial. Kita akan bincang tutorial 3. Okay, so please make sure try the tutorial before we have the discussion next week. Dan make sure juga kamu buat tutorial 2. Semua soalan, jawab semua soalan. Okay. Kalau ada pertanyaan tentang tutorial 2, then you can ask me as I said just now lah. Okay. During working hours, working days, or live session. Okay. So itu sahaja daripada saya. Terima kasih semua. Kita jumpa Jumaat nanti untuk lecture dan juga tutorial minggu hadapan hari Isnin online juga. Okay, terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam doktor.
Thank you doktor.
Thank you doktor.